Okay, welcome back. Should be our fourth and final video here. So now we're going to take all three individual transformations that we looked at and combine them, because we know we don't live in a world where it's just one single thing at a time. It would be nice if all we did was move left or reflect or stretch or shrink, but we don't. We know that. So I know this is a scary looking formula, but all that is a combination of all the previous videos we just watched, right? The A in front, that was a dilation, vertical dilation. The B on the inside, that was a horizontal dilation. H was the horizontal translation, K was the vertical translations, right? And A and B could be negatives as well for the reflection component. So we are still going to follow the same process. Horizontals are insides, substitutions. Verticals are outsides, distributions. And we are going to read through sentences of movements that they tell us. And it's really important, as I highlighted in green there, that we apply the transformation in the order in which it describes. But we're going to do one at a time. One transformation and then whatever it's followed by. If you caught on really quick, you do have the ability. You can do it all at once. But for learning purposes, I'm going to break it down very, very simply, one at a time. So let's dive into this problem. Right? So we have our original function, back to the parents, f of x equals x, nice and basic. And we see that it says it is a vertical shrink by a factor of 1/3 followed by a translation 4 units down. So that word followed by, that little phrase there, it breaks it into the two movements that we're doing. The first one being this vertical shrink. So obviously it's vertical, so that's going to be outside. It's going to be distributed. And I know that that is the A value. A is 1/3. I need that information. Followed by, okay, the second thing I then have to deal with is a translation 4 units down. Okay, down to me is vertical. That's going to be an outside issue. That is the plus k at the end. And if it's 4 units down, k equals -4. And again, just like in the other video, I apologize for all the random lines happening from my pen use here. Okay, one at a time. Start with the first one. So vertical shrink by a factor of 1/3. When I go back to my notes, I saw that anything vertical stretches or shrinks was the function AFX. I know A. A is 1/3, right? So this tells me my g of x function, and this is just like the previous video we did on dilation. I'm going to replace the A with the 1/3. It's going to cause it to be a distribution to whatever the function is. Okay, let's do it. So g of x equals 1/3 times f of x. And again, f of x being that original function, this is the original. Well, the original is just x. When I clean that up, I have g of x equals 1/3 times x is just 1/3 x. Okay, that's step one. We finished the first transformation. Now, what's going to be important is when we get to step 2, we need to use this one for step 2. Because we can't go back to the original. We've already changed the original. So I need to make sure I'm going to use that when I get into this next component. Okay, so I can't use G again. I already used it for that name. So I got to use a different letter. I'm going to go alphabetically. I'm going to just move to H. You can name it whatever you want. Again, I just need to come up with right now the generic formula for translations vertically. So usually it's f of x, but again, as I said, we want to use this guy down here. So his name was G, so that's what we got to put in. So g of x plus k. I know k. K is -4, so let's fix that. H of x equals g of x plus -4. Again, we don't like those double signs, so I'm going to clean that one up. H of x equals g of x minus 4. Okay, here's where we want to use it, right? So g of x, that function that I just found in the previous step, I now need to insert here. I'm not distributing, I'm not substituting in for an x, I'm substituting this whole entire equation is going to be placed into the g of x function. Okay, so h of x equals, instead of g of x, I'm going to replace it 1/3 x, and then I have that minus 4 at the end. I would clean it up. There's nothing really to do. There's no distribution, nothing I can combine. So my final answer is, if I take a single x and I shrink it by 1/3 and I translate it 4 units down, I end up with 1/3 x minus 4. Okay, there's a couple more of those for you to try, and I would like for you to try them on your own and check in. Again, I will be posting the full answer key. But let's take a look at an actual application for you guys. So this one's kind of normal to you, right? We all do ride shares at one point or another, or we've seen or heard about them. So let's take a look what happens. The cost in dollars of a ride from a rideshare company during regular hours is f of x equals 2.3x. So that's probably going to be really important to us. X is the number of miles driven. The cost of a ride during high demand hours includes a tip of $5 more than 120% of the regular cost. What is the cost of a 6-mile ride during high demand hours? Okay, so we all know this, right? They can do surcharges during high demand hours or high demand places. If you ever left a concert or a sporting event, you know sometimes they jack up those prices of the ride shares to get you home. So let's talk about that for a moment. So first of all, 120%, that is the surcharge. I don't throw percentages inside a function. We don't use percent signs. So let me just write this. So it's $5 more than 120%. I'm just going to put regular. 120% of the regular. Okay. If I was to go in order with this, the $5 more, we should understand that means we add $5 to it. And then we have 120% of the regular. Okay, again, as I was saying, we don't put percentages inside things. So I want to convert that 120% into a decimal. If you don't know how, you take the 120%, you divide it by 100. I have 1.2. So that's the surcharge. It's 1.2 of the original amount. So when I come up with this function, this new function, well, if it's 120% more than, right, percentages are multiplying. I'm going to take that 1.2 and, I'm going to multiply it to the original. So 1.2 of the 230. And then the $5 more, we already said that was plus 5. So there's our combo. We didn't have to do it step by step like in that previous one because it made sense that I would multiply the original, 120% of the irregular, and then add $5 to it. Doesn't matter when I add the $5, it's happening. And then when I clean this up, I would distribute. I get g of x equals 2.76x plus 5. Question's asking, how much is it for a 6-mile ride? So in that case, all we're going to do is substitute a 6 in for my x. Everywhere I have an x, I'm replacing it with a 6, and then I'm going to figure out what it costs. So 2.76 times 6 plus 5, I would just put that in a calculator, and that would tell me it's going to cost about $21.56 for us to go on that ride. Again, there's similar word problems here. Give them a try. Make sure you check the answers with the posted answer key when you're done.